Hello students, welcome to my channel. So today's class 9 we are going to do Theorem 6.2. So Theorem 6.2 is given if a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. So this is the theorem and we need to prove it now. So first we will draw two parallel lines. So one parallel line is this one, another parallel line is this one, and we will draw one transversal which cut it. So as a hex we can keep. So these are lines, and we will consider as the lines as A, B and CD, and the transversal is PQ. So AB and CD are parallel lines, PQ is the transversal. We need to prove alternate interior angles are equal. That means I'm marking here this one is equal to 2. This one we have to prove. Now how will you prove this one? So first we will write what is given. AB parallel CD. PQ is the transversal. To prove angle 1 equal to angle 2. So angle 1 equal to angle 2 we need to prove. But we will take one more angle here, that is 3. So now proof I am going to do. In proof what we have to do, from the diagram you can see, we can see from the figure that angle 1 plus angle 3 is equal to 180 degrees. What is the reason? Because they are linear pair. That means they are on the same straight line, sum of them will be equal to 180 degrees. And also we can see there angle 1 plus angle 2, sorry, angle not angle 1, this is angle, which angle is there? Angle 2 plus 3, angle, also angle 2, angle 2 plus angle 3 is also equal to 180 degrees, and that is, this is, first one we will mark as equation number 1. 2 plus 3, why 180 degrees? Because they are interior angle on the same side of transversal. Already it is given that lines are parallel. So interior angle on the same side of transversal we can write co-interior angle. So this one we can mark as number 2. Now 1 plus 3 180, angle 1 plus angle 3, and angle 2 plus angle 3 also 180. So from 1 and 2 we can write what we can get here, that 1 plus 3 is equal to 2 plus 3, and both sides 3 cancel. So what is left? Angle 1 equal to angle 2. So it is proved. So first proof is done. Theorem 6.2 is proved. Theorem 6.3 given if a transversal intersects two lines such that a pair of alternate interior angle is equal, then the two lines are parallel. So theorem 6.3. Theorem 6.3 is given if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. So this is the theorem, and the same diagram we need for that. This time lines parallel not given, that means we have to prove that these two lines are parallel. We will prove. Diagram will be same, naming also same. I will give A, this one is A, this is B, C, D, and the transversal is PQ. So now here already given that the alternate interior angles, one pair of alternate interior angles are equal. So suppose I am writing here this one is equal to 2. Now we have to prove that these are the lines are parallel. So how to prove it is. So here I will take another angle, that one is 3. So first we will write that AB and CD are two lines, PQ intersect AB and CD, both angle 1 equal to angle 2 given, that is alternate interior angle, and we have to prove AB is parallel to CD. So here now what we will do, from figure proof I am going to do. So from figure, what you will get, angle 1 is equal to angle 3 also not. These are vertically opposite angles. So vertically opposite angles always equal. And also we have angle 1 is equal to angle 2 according to the question it is given. So therefore can we write 2 and 3 are equal, because 1 is equal to 3 and 1 is also equal to 2, so 2 and 3 are equal. But angle 2 and angle 3 are corresponding angles. So corresponding angles when equal, when lines parallel, then only corresponding angles equal. So therefore we can write AB parallel AB. This one also good. Students, you can try to prove other theorems. Now I'm going to start exercise 6.2. So exercise 6.2, question number 1. Diagram is given something like this. Two lines there, one is this one, another is this one, and one transversal cut. So this line is given as AB, this line is given as CD, and transversal name is not given. This angle is given 50 degree. This angle is given X, this angle is given Y, and this angle is given 130 degree. So X and Y we need to find. So and I have to prove AB parallel CD. So question nothing is there to find X and Y and to prove AB is parallel to CD. So the solution I am going to do here. So from the diagram you can see, first of all, X and 50 degree are in linear pair. So we can write X plus 50 is equal to 180 degree because they are on the same straight line. So they are linear pair. So X equal to 180 minus 50. So we will get 130 degree. X getting 130. Also from the figure you can see Y is equal to 130. Why? This is vertically opposite angle. So Y is also equal to 130 degree. Now you can see X and Y are alternate interior angles. They are becoming equal. So since X equal to Y and they are alternate interior angles, therefore we can write AB is parallel to CD. The first question done. Let's move to the next question, question number 2. So question number 2 given that three lines are there, AB, CD and EF. So let us draw that first. So AB, CD and EF, three lines there, and one transversal cut all three lines. This is the diagram. First is given AB, second one is CD, third one is EF. And here X given, this one is given Y, and this is given Z. So in the diagram only you can see opposite angle of Y, vertically opposite angle also will be Y. So if you write in the diagram only, that one is Y. And in the question it is given now AB is parallel to CD, CD is parallel to EF, Y is to Z, 3 is to 7, and we need to find X. So let us do it now. So solution, because it is not proof, we have to find a value. So AB parallel CD given and CD parallel AB. So AB parallel CD means X plus Y will be 180 degree. Is it? Yes. So we will write AB parallel CD. So x plus y equal to 180. Why 180? Because co-interior angle means interior angle on the same side of transverse. So this is number 1 I'm marking. Then already vertically opposite angle we have written there. So CD parallel EF given. So therefore we can write y plus z. Y plus z also equal to 180 degree. Y plus z also 180 degree. Now this one also same, region is co-interior. Now you can see here ratio is given, y to z is 3:7. So we can suppose the angle. Next we will suppose let y is equal to 3a and z is equal to 7a. I am not taking x because already x angle is there, so 3x and 7x not taking. So therefore y plus z was already 180 was there. This one is there only. Since y plus z 180, therefore 3a plus 7a also equal to 180. So this one will be 10a 180. So a will be equal to 180 by 10. So we will get 18 degree. Now we have 18. So y is equal to 3 into 18 because 3a was there. So 54 getting. And z is equal to 7 into 18. 718 means 126. So 126 is that we are getting. So now we can get x by putting x plus y is equal to 180 was there. We can put there the value of y and 126 we can get. Or directly also we can put, because AB parallel CD, CD parallel EF, so AB also parallel EF. So since already we have supposed equation number 1, so I will put here. That means I am doing mathematically directly, so putting the values. Otherwise we can write like this also, AB parallel CD, CD parallel EF. So therefore AB parallel EF. The equals are how axioms are there. Euclid's axiom, equals are equal to equals. So parallels are equal, parallel to the parallel. So same thing will be applicable here. So x plus 54 is equal to 180. So we can write x is equal to 180 minus 54. That is 126. So this is question number 2 finished. Now going to do question number 3. So in question number 3, first let us draw the diagram. What is given in the diagram? There is a line like this, and then another parallel line is there, and one perpendicular line is given, and then one line from here it is joined with this perpendicular. So naming is given. How? This one is AB, this line is CD, then this one is F, E, and this angle is, this point is B. So here given that AB parallel CD and given EF is perpendicular to CD, angle ZED is given, that one is 126 degrees, and now we need to find these all angles. These angles, one is AZE, one is ZF, and another one is FZE. So first one AZE directly we can find because here you can see ZED. This is the ZED angle. Here ZED angle is written by another color. I'll show you. this is the ZED angle. So ZED angle and AZE are alternate interior angles because lines are parallel, AB and CD parallel, alternate interior angle will be equal. So whatever ZED, AZE also will be the same. So we will write that. Since AB parallel CD, therefore angle AZE is equal to angle ZED, and that one is what type of angle is this? Alternate interior angle, in short form I am writing. So therefore angle AZE we can write 126 because ZED is 126 given. So one angle we have got. Now we need to find out ZEF. So we have EF perpendicular. EF perpendicular to CD is there. Therefore FED angle will be 90 degree. And we have ZED. From ZED, in the diagram I will show you, from this ZED angle, this one ZED, from ZED if I subtract this FED, we will get ZEF. So that one only we will write. Therefore angle ZEF will be equal to angle ZED minus FED. So ZED is 126 degree, FED 90 degree, so we will get 36 degree. So we have got angle ZEF. Now FZE and AZE are forming linear pair. From the diagram you can see. So again angle AZE plus FZE equal to 180 degree because they are linear pair. AZE 126 degree, FZE not there, need to find out. So angle FZE 180 minus 126, 54 degree. So the three angles which one we need to find, already find out. Question 2 finished. Let us go for question number 4. So question number 4, here given PQ parallel SP. So first diagram I am going to draw. What is the diagram? The diagram is something like this. This one is there, one line, another one line. From here one more line. This is another line. So this one. Arrowhead. P, Q, R, S, C. Some angles given. This is 110. Then this is 130. And here one construction we will do. So one construction I am going to do here. One line parallel to SC we will do. This is SC, so parallel line. I will do full parallel this one. This is the parallel line have to go. And you can name it something. Suppose everything is given here, you can write AB here. So this is the parallel line drawn. And here we will mark angles. This is 1, this is 2. So first you have to write what is given in the question. PQ is parallel to SC given. Then angle PQR equal to 110. Then angle RST is given. That one is given how much? 130 degree. And you have to find angle QRS. So now one construction we have done here. So construction is what? AB parallel PQ parallel FC is drawn. It's parallel to FC drawn, since PQ is also parallel to FC, so it is parallel to PQ also. Now from the figure you can see angle 1 and 110 are interior angle on the same side of parallel transversal. So first we will write in solution, since PQ parallel AB, therefore angle 1 plus 110 equal to 180. So co-interior. So angle 1 is equal to 180 minus 110. 1 is equal to 70 degree getting. Again, FC is parallel to AB also. So therefore we can write angle 2 plus 130 equal to 180. This one also co-interior. So therefore 2 is equal to 180 minus 130, so 50 degree. Now you can see again in the diagram that angle 1, 2 and QRS, which one we have to find out, are on the same straight line. So that means sum of them will be 180 degree. Now angle 1 plus angle QRS plus angle 2 equal to 180. Reason is what? Angles on same line. So angle 1 is how much? 170 degree getting. 70 degree. And plus QRS we need to find out. And this one we have got 50 degree is equal to 180. So QRS will be equal to 70 plus 50, 120. Directly I am subtracting. So 60 degree is the answer. So this is question number 4 done. So today's class 9 we are going to do theorem 6.2. So theorem 6.2 is given if transversal intersects two parallel lines, then each pair of alternate interior angles is equal. So this is the theorem and we need to prove it now. So first we will draw two parallel lines. So one parallel line is this one, another parallel line is this one, and we will draw one transversal which cut it. So as a hex we can give. So these are lines, and we will consider as the lines as A, B and CD, and the transversal is PQ. So AB and CD are parallel lines, PQ is the transversal. We need to prove alternate interior angles are equal. That means I am marking here this one is equal to 2. This one we have to prove. Now how will you prove this one? So first we will write what is given. AB parallel CD. PQ is the transversal. To prove angle 1 equal to angle 2. So angle 1 equal to angle 2 we need to prove. But we will take one more angle here, that is 3. So now proof I am going to do. In proof, what we have to do, from the diagram you can see, we can see from the figure that angle 1 plus angle 3 is equal to 180 degrees. What is the reason? Because they are linear pair. That means they are on the same straight line. Sum of them will be equal to 180 degrees. And also we can see there angle 1 plus angle 2, sorry, angle not angle 1, this is angle, which angle is there? Angle 2 plus 3, angle, also angle 2, angle 2 plus angle 3 is also equal to 180 degrees, and that is, this is, first one we will mark as equation number 1. 2 plus 3, why 180 degrees? Because they are interior angle on the same side of transversal. Already it is given that lines are parallel. So interior angle on the same side of transversal, we can write co-interior angle. So this one we can mark as number 2. Now 1 plus 3 180, angle 1 plus angle 3, and angle 2 plus angle 3 also 180. So from 1 and 2 we can write what we can get here, that 1 plus 3 is equal to 2 plus 3, and both sides 3 cancel. So what is left? Angle 1 equal to angle 2. So it is proved. So first proof is done. Theorem 6.2 is proved. Theorem 6.3 given, if a transversal intersects two lines such that a pair of alternate interior angle is equal, then the two lines are parallel. So theorem 6.3. Theorem 6.3. Theorem 6.3 is given if a transversal intersect two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. So this is the theorem, and the same diagram we need for that. This time lines parallel not given, that means we have to prove that these two lines are parallel. We will prove. Diagram will be same, naming also same. I will give A, this one is A, this is B, C, D, and the transversal is PQ. So now, here already given that the alternate interior angles, one pair of alternate interior angle are equal. So suppose I am writing here this one is equal to 2. Now we have to prove that the lines are parallel. So how to prove? It is one. So here I will take another angle, that one is 3. So first we will write that AB and CD are two lines, PQ intersect AB and CD, both angle 1 equal to angle 2 given, that is alternate interior angle, and we have to prove AB is parallel to CD. So here now what we will do, from figure proof I am going to do. So from figure, what you will get, angle 1 is equal to angle 3 also not. These are vertically opposite angles. So vertically opposite angles always equal. And also we have angle 1 is equal to angle 2 according to the question it is given. So therefore can we write 2 and 3 are equal, because 1 is equal to 3 and 1 is also equal to 2, so 2 and 3 are equal. But angle 2 and angle 3 are corresponding angles. So corresponding angles when equal, when lines parallel, then only corresponding angles equal. So therefore we can write AB parallel AB. This one also good.